The fastest spaceship we've ever launched, if aimed at the closest exoplanet, could potentially reach a destination called Proxima. It's close in astronomical terms at only 4 light-years away. Scientists speculate that we may one day pick up signals from an extraterrestrial civilization on another planet very similar to Earth, one where a civilization like ours could exist. The closest star system to us, Proxima Centauri, actually hosts a fairly Earth-like planet known as Proxima Centauri b. Astronomers have recently made an unexpected discovery on the dark side of Proxima Centauri b, a side that has never seen the light of its star. For years, this region was thought to be a cold, lifeless shadow. However, new observations have revealed something faint yet unmistakably out of place emanating from the darkness: emissions from the planet's dark side. As scientists peer deeper, it's becoming clear that these faint but distinct signals might be unlike anything we've encountered before. These emissions could take various forms, such as artificial light, heat radiation, or other types of electromagnetic radiation like infrared. These signals differ from natural starlight, bearing unique signatures that could mark them as man-made or the product of a sophisticated system. Unlike the constant glow of a distant star, these emissions can be detected using powerful telescopes like the James Webb Space Telescope, JWST. This instrument is specifically designed to detect faint infrared radiation, exactly the kind of energy that might escape from Proxima Centauri b's dark side. Intriguingly, these emissions may hint at more than artificial lights. They could point to a hidden civilization or a deeper mystery we have yet to unravel. If these emissions are artificial, they could provide insights into the planet's inhabitants. The patterns of light and heat might reveal the types of technology in use, the scale of energy production, and even hints about the social structures of the civilization. Much like Earth city lights tell stories of economic power, political boundaries, and infrastructure, the emissions from Proxima Centauri b could similarly reveal an alien society's priorities and values. These faint signals might offer a glimpse into a completely different way of life light-years away. The tidal locking of Proxima Centauri b profoundly impacts its emissions because one side of the planet always faces its star, while the other remains in perpetual darkness. The dark side is extremely cold and inhospitable. Artificial lights and energy sources would likely be essential for any life to exist there, providing warmth and illumination to make the dark side habitable. Without these technologies, the dark side would be too cold and dark to support life as we know it. The consistent nature of tidal locking might result in steady and predictable artificial emissions, making them easier for astronomers to detect. Future telescopes like the JWST and the proposed Large Interferometer for Reflectivity L are designed to detect incredibly faint emissions. These advanced instruments can capture narrow bands of light, particularly in the infrared spectrum, which is crucial for identifying artificial emissions. Unlike the natural starlight that floods our observations of distant stars, these signals would stand out, enabling astronomers to detect something far more exciting: signs of intelligent life. What sets the JWST apart is its ability to focus on specific wavelengths of light emitted by artificial sources. Its infrared sensitivity allows it to detect heat radiating from a planet, even from light-years away. By analyzing these wavelengths, astronomers can differentiate between natural starlight and the unique signature of artificial light. This capability marks a groundbreaking shift in our search for life beyond Earth. The technology could enable us to spot a distant civilization by detecting patterns of light unlike anything we've seen before. For Proxima Centauri b's dark side to be habitable, extraterrestrial civilizations would need advanced technologies to generate light and heat. One possibility is the use of photovoltaic panels, solar cells that convert sunlight into electricity. Though the dark side doesn't receive direct sunlight, these panels could be installed on the permanently sunlit side of the planet, harnessing solar energy and storing it for use on the dark side. Such innovations would allow life to thrive in an otherwise inhospitable environment. Other advanced energy sources might include nuclear fusion reactors, which could generate vast amounts of power without relying on solar energy, or even something like artificial photosynthesis, a technology that mimics the process plants use to convert light into energy. These artificial lights would serve two key functions: to provide light and to warm the dark side, making it livable. Just as Earth relies on electricity for everything from streetlights to homes, Proxima Centauri b's inhabitants could depend on sophisticated lighting systems to not only illuminate their world but also maintain a habitable temperature in constant shadow. Could these artificial lights indicate something much larger? Perhaps an advanced technological society. The lights themselves may not be just a survival mechanism. They could point to a civilization with remarkable energy management and engineering capabilities, and the ability to control their environment on a scale we have not yet imagined. While emissions from the dark side of Proxima Centauri b have been detected, significant challenges remain in fully understanding or analyzing them. The vast distance between Proxima Centauri b and Earth makes it extremely difficult to isolate the faint signals coming from such a distant world. Even with the emissions we've detected, their faintness makes distinguishing them from background noise challenging. Additionally, Proxima Centauri's solar flares and cosmic radiation further complicate the task, potentially interfering with the clarity of the signals we're trying to study. Advancements in telescope technology, however, are pushing the boundaries of what's possible. Instruments like the JWST and future telescopes like L are designed to focus on specific wavelengths of light, including the infrared emissions that could originate from Proxima Centauri b. These highly sensitive instruments allow astronomers to isolate these emissions with greater accuracy despite the distance and interference from cosmic phenomena. Could Proxima Centauri b's natural emissions confuse scientists into thinking the planet is just another barren rock? Despite breakthroughs in detecting emissions, it's still possible that what we've identified is just the beginning. With the right advancements in technology, the real story may yet remain hidden beneath a layer of cosmic noise. While emissions from Proxima Centauri b's dark side have been detected, some of these signals could represent natural phenomena rather than artificial lights. Earth itself provides examples of such emissions, like the shimmering auroras caused by interactions between solar wind and our magnetic field. On Proxima Centauri b, volcanic activity or atmospheric phenomena like auroras could produce similar glowing emissions. The planet's unique position, constantly facing its star on one side, could lead to dramatic volcanic or geothermal activity, releasing heat and energy into the atmosphere. This complexity makes distinguishing between artificial light and natural emissions particularly difficult. Just as auroras on Earth can appear bright and otherworldly, volcanic lighting or intense storm activity on Proxima Centauri b might give off emissions that could be mistaken for a city's glow. The faintness and irregularity of these emissions might cloud our understanding of what's truly happening on the dark side. Could Proxima Centauri b be hiding something beneath its surface? What if these emissions are not from a city but from a planet teeming with volcanic activity? The mystery beneath the planet's surface might be far more complex than we ever imagined, suggesting that the dark side of Proxima Centauri b could hold more than just a few lights. It could harbor a dynamic, ever-changing environment. Proxima Centauri b's atmosphere could significantly influence the emissions detected from its dark side. If the planet has an atmosphere, it might act as a filter, altering or absorbing certain wavelengths of light before they reach our telescopes. This means that even if artificial lights are shining brightly on the dark side, some of that light might be absorbed or scattered by the atmosphere, making detection more difficult. The composition of Proxima Centauri b's atmosphere, whether it's rich in gases like carbon dioxide, nitrogen, or exotic compounds, could change how the light behaves as it travels through. For instance, certain gases can absorb specific wavelengths of light, altering the light's spectral signature by the time it reaches our instruments. This implies that even though we might detect something from the dark side, its true nature might remain unclear without considering how the atmosphere has affected the emissions. What if Proxima Centauri b's atmosphere holds the key to understanding the emissions from its dark side? The way the atmosphere filters these emissions could provide insights into the planet's history, how it developed, the environmental changes it has undergone, and whether it's capable of supporting life. By leveraging the power of next-generation telescopes like JWST and L, we are on the brink of unlocking profound discoveries. These instruments could reveal faint emissions from Proxima Centauri b's dark side, potentially unveiling signs of life or technology on a distant world. With these breakthroughs, we will not only answer questions about the planet's habitability but also open the door to exploring what could be an entirely new chapter in our search for extraterrestrial life. The future of space exploration is thrilling, and with each advancement, we get closer to discovering whether we are truly alone in the universe. These discoveries will change everything we know about the cosmos. We are standing on the edge of something monumental.